Okay, let me make you so this morning we are going to go back to revise in the first 30 minutes what we did last week, and which is actually solar PV sizing, or will I say the manual design.
Yes.
So solar PV sizing and calculation. So after this, we'll try to use the software to model what we have already designed. The software will now help us to come up with a workable model, and then we can then simulate different scenarios. So this is exactly what we did last time. Let's assume this is a standalone system. The software does three things. It does the grid connected system, it does the standalone system, and it does the pumping system. Yes, these are the three areas of application of the PV solar system. You can use it for pumping, you can use it for stand-at-home system, and then you can use it for grid. And for the grid, there are different grid, distributed grid, off-grid, on-grid, and what have you. So here we have our equipment. This can be up to 100, it can be 10, it can be whatever number. We have their quantities, then we have their individual power ratings, then we have their power demand. So this multiplied by this will give you this. So 8 number of 15 amp watts bulb will give you 180 watts total. Then how long do we use them in our houses? We must do this. This is very important for the software also. You calibrate this and look at how many hours you can use them. Then you now multiply the power times time. Power is the rate of doing work, right? So that means energy is power times time. If you do it, make it the subject of the formula. So this becomes here 600, this and this. And last week we made it known that you need the power to size your inverter, because the inverter is what interfaces with your load directly, right? Vis-a-vis conversion of DC to AC. Then you use your energy requirement to size your battery. So with those two in place, you can now use the battery to size your PV cell, PV module, right? Because it's the PV module that will charge the battery. You can also use the battery to also size your generator in case of a hybrid system, right? So once again, we talked about the issue of power factor, and most inverters are rated in kilovolt ampere, right? So for you to get the inverter size, the inverter size is as good as the power demand, but because of the issue of load factor and power factor, which are more like safety factors, right? You divide them with this, that will scale it up. So I want us to see this as a scaling up factor. So instead of you going for inverter size of 410 watts, which is the actual, you now upscale it to 650. Then move to the battery. Because you're working backward. From the battery, we'll now move to the maybe charge controller and then the PV. Okay, so for the battery, our total energy need based on the hour of usage was 340 kilowatts hour or watt hour, or 400 watt hour, just dividing by 1,000. Then we decided to have 2 days of autonomy or backup, and if you do that, you're going to get 10,200 watt hour. However, depending on the type of battery we are using, lead acid battery, lithium iron phosphate, and Tesla, and so many of them, we're going to see them in the software. But now we are using, because we're using a lead acid battery, which has an efficiency of 50% in quotes, we now have to divide the total energy need by that efficiency of the battery, or what we call the depth of discharge, right? I try to use these things interchangeably so that even a layman will understand it. So at the end of the day, we now have 20,400 So this becomes our target value for the design. So based on that, we now design our batteries. So, but to further make us understand how we came about the design of this battery, we are taking back to our primary electricity basics, which is to say that since power is volts times ampere, ignore this power factor, right? Ignore this power factor for now. So it means that if you now multiply power times time, it will be VIT. If you match I and T and just make T to look hourly, it will become AH. So every battery in the market is rated based on the voltage it can take and the amp hour, sorry, it's the same thing, the amp hour. So following that sequence, we now go to our markets and then decide which battery we will need. So here, if you have 2,400, you have done the design, but depending on the availability of the battery in the market, if I have 12 volts, 100 ampere, that will give me 1,200. I will now divide this by 1,200. That will give me the number of battery rated 12 volts, 100 amps. But if I'm using 48 or 24 times 200, of course, that's a bigger battery, that's a higher capacity battery. I will just multiply the two, amperage plus the hour, it will sustain it, divided by this. So we further did this example here. So in this example here, from what we've done so far, 2 days autonomy, we are using a battery of 12 volts, 200 amperes. Now, this voltage 12 volt battery, we have for now in the market, I think we have up to 72 or 96 volt battery. It depends on the higher load. As soon as the load is getting higher, the lower voltage batteries are not convenient anymore. It means you need a higher number of them. So as the equipment is going higher, you are getting more higher voltage. So if you are designing for less than 300 watts system, 12 volt will suffice. If you are designing for 24 volt system, if you are designing for a load that is less than 1,000 watts or 1 kilowatts, then you can go for 24 volts. But if you are going for something less than up to 3,000 kilowatts, then 48 volt system. If you're not going for a higher value, you go for 72 volt system. So that's how the gradation goes. Okay, so from here, we now we multiply the voltage times the amp hour. It gave us 2,400, which is 2.4 kilowatts. We now divided it by our total load size. So that will now give us So that will now give us 8.4 battery, 8.5 battery. So here, you either use 10 batteries or you use 8 batteries. So somebody's raising a hand. John Richard, what's the question?
Thank you very much and good morning. Please, in the calculation for the size of the inverter, last week Engineer Chima said that since we are working with watts, we should remove the factor of the power factor, but it's still inclusive in your explanations.
Okay, I forgot that. That's right, because you're right. We're supposed to remove it, so we'll just remove it there.
Blaze, what are we removing?
Okay, let me go back. Here, most inverters in the market are rated in. Here you see kilovolt ampere, kVA. So kVA, if kVA is the size, this is what. So it means that this answer here should be kVA, not watts. So this value now would be, if you remove this, it will now be kVA. All right. So if you remove this, you now, what you get will now be in watts. So the final wattage should be more than this, maybe 670. I don't know what we had last week. Is that clear?
Yes, it was more than that.
Yeah, it should be more than that, because if you remove 0.9, if you eliminate 0.9, but the resulting answer will now be in kVA. So in other words, the convention is changing. Prior to now, it always kilovolt hour, kVA, that they rate the inverter. But the newest inverters that are coming on board now are going on watts. So it's either you work on watts or you work on kilovolt, or you work on kVA. kVA is the apparent power.
So what we had was actually 585. I mean, when you remove the 0.9, you have 585.7 watts.
Yeah, you have a lower value.
Yes, that's what we got.
Yeah, because divided by 0.9 scales it up. Okay, any other question?
Kinsley raised his hand. I don't know if that was from the previous question.
Can you hear me? Sorry.
Yes, sir. What did you say, sir?
Okay, so, sorry, just a quick one. I want to confirm, since we have different batteries in the market with different voltage ratings, ranging from 12, 24, 72, 96, 48, as the case may be. Now for the inverters, the input to the inverter, which is DC, do they have a range? Do they accept a range of DC input also? Or you now need to buy an inverter with an input requirement voltage similar to the battery output voltage?
Yeah, you have to go for compatibility, and they are all written, they are spelled out. You have to go for compatibility. If it is 48 amps, 48 volt system you are using, you go for systems that are compatible with it. If it's 72 volt system you are using, you have to go in that order. Unless the manufacturer gives you a way to string them, or a way to connect them either in series or in parallels. But you must go for compatibility. And that's why there are different types. And this is where the design comes in.
Okay.
Hello.
Okay,
Yes.
so I can't.
Hello.
Sorry. So okay, somebody wanted to say something.
Hello, sorry, please. I'm cutting you short. I just came in. I just logged in. I wanted to confirm. I thought we are treating the software today.
Yes, but we promised to, because of those who seems lost last week, we said we will dedicate the first 30 minutes to like glance through, scan through what we did last week, and that's exactly what we're trying to do.
It's okay. Okay, thank you.
Thank you. So let me be faster now. So please, Jachim, I don't know. Let's if you have any question, go to the somebody's trying to access something on the platform, on the chat room. Please, you reply so that we can get going. Thank you.
Okay.
I appreciate everyone. Yes. So we are out of this. So then the next thing we move to the required energy output. That is the PV, which is meant to charge the battery now. And we said the total output divided by peak sun hour. And we were advised last week to use 5 hours for Nigeria, even though you can go above that, but I mean, you need to move in the direction of safety. So at the end of the day, we also assumed a performance ratio. Since standard test conditions might not be met in our sites, we further added another safety factor of 0.75, which is like multiplying by 1.25, right? And then that will scale up the number of PV cell that will require, right? So this and this is just like multiplied by 1.25, which is like increasing. In fact, I will want to advise somebody that if you are doing a pumping system, you should provide 50% extra. In other words, you should multiply your performance ratio should be 0.5. Yes, that's my own from field experience. But for pumping, because what we discover in pumping is that shading is always there, especially for all these off-site boreholes. You see them siting these boreholes where you have shadings. Then most times sun is not maximum. The sun peak hours, used in the design is not met, and cloudy condition comes in, and many other dust comes in, contractors grid comes in, many things comes in, that is advisable that you increase your PV cell requirement by a factor of 50%. Yeah. But here we're only increasing by 25%, which is more like the minimum, the base minimum for everyone. So from here now, this is the number of solar panel you need. So what you now have to do here is now to divide by the available market specification, right? If the BOQ or whatever now said 300 watts or 250 watts or 100 watts, you now divide it by this number. Assuming it says 100 watts panel modules, that means we need about 55 pieces of them. If we need 200 watts, if I divide this by 200 watts, it means I need 25 pieces of them. And if I am able to import the latest in the market, which is about 1,000 watts from Canadian Solar and the rest of them, that means I need only 5 pieces of solar panels to do this. I hope that's clear.
I saw him with the earphones.
Right? Then the next thing,
inside the car.
The next thing, please, let's mute ourselves. Thank you so much.
This boy was up to something.
Okay. So the next thing we do is to size the charge controller, right? And that charge controller is a function of the system voltage. In this case, it's 12 volts. And because it's 12 volts, of course, you'd expect a very high amperage, right? But then, as we know, practically, this might not be feasible. We now string them, maybe in 2s or in 3s. That will bring it down considerably. I guess no question so far. So that is what we did last week. So this morning, we're going to the software components. And
hello, sir. I have a question on the charge controller.
Okay.
My question is, are you I thought you'll be dividing by the voltage of the inverter. We're not using 12 volts now. If the inverter is a 48 volts inverter, I think that power should be divided by 48 so that we can know the current.
Our case study is 12 volts, sir. That's why we divide by 12.
Okay, the inverter is 12 volts.
Yes, sir.
Okay, so if inverter is 48 volts, it will be divided by 48. If it is 24 volts, it will be divided by 24. Is that right?
Yes.
Okay. Go on, sir. Go on.
But you don't say inverter voltage. You say system voltage. Okay.
Okay. System voltage. When I say what I mean by inverter voltage is the primary voltage to the inverter. That's DC.
Okay. System. Yeah. That's another way of saying.
Okay. That's okay. My question is answered. Thank you.
Appreciate. Right. So now let me say this, and I want to say it again with authority. I've been teaching a lot of softwares, and when you come for software training like this, we don't expect you to understand everything on day one, but as you practice it, as you gloss over it, you become perfect in it. So this is why I would like to crave our indulgence that after today, I don't want you to go home and assume I'm an expert in PVCs. Even me that is teaching you, I've only learned some components that are more like what I want. But the system, the software is loaded. It has a lot of things to do. You have a lot of things to teach you, but it's not something we're going to spend the whole 3 weeks or 1 week and learning. Although I plan in the future to have a dedicated class to teach this software and maybe add it to Homa or one other software. So this is what the interface looks like. Are we with me? So as with every software, you always have this tax bar, yeah. Then this is, it gives the name of the software. It's telling me I'm on a trial one. And I think at this point, I need to give us this slide. We have it already. So this is what the software looks like. This is what the interface of the software looks like. It's a Swiss software. We currently have version, okay, I prepared this when it was version 7.0. Now we have version 7.2. So they keep improving every day. So this is the address in Switzerland. Then this is what the software comprises of. There's a general description about the software. It will give you the tool interface. So this is the description of the software. This is the tool interface. You could do a preliminary design with the software. you can also do a project design. So irrespective of the design you are doing, you can do a standalone system, you can do a grid connected system, and you can do a pumping system. So there are three basic things you can do with the software. Standalone system, maybe home system, it could be medium system, it could be high system, right? I have said it before. Less than 300 watts is low, and you can use 12 volts system. Less than 1,000 watts is medium. You can use 24 volt system. Then less than 3 kilowatts is a high standalone system. And you can use, you are recommended, let me use the word, to use a 48 volt system. There are 96 volts now in the market, and they will only get better. But the principle will remain the same. Then you can do a grid connected system. Then you can now do your pump estimation. So it's a software package. I mean, you can read it. You can read this up. You can read this up. I'll read this up. Okay. Any questions?
Hello, sir. How do we get the software? I'm just joining the class today. How do I get the software?
I'm on the class.
Hello.
Hello. Yeah. The software, you can download the software. I think for the first month it is free. Then after the first month, you have to pay if you want to continue using the software.
Can
you hear me?
Yeah, I can hear you, sir.
Yeah, he's asking how he can get the software, and I said he can download it for free and use it for the first month. But after that, he needs to pay to continue using it.
Yeah, I think we've said it like repeatedly.
And how much is it, please, if you want to download it?
It's 700. Now you might not need. It's $700, right? But as I said last time, you can use it for the first 1 month, and there's a way you can also register again, maybe use a different system or so. You can still have it. So I don't think you should bother yourself about the cost for now until maybe there's something that will pay for it, right?
Okay, thank you.
Okay. Okay, so this is what the software is. So let me continue. One of us is just distracting me. She can't log in. What have you? Okay, preliminary design, project design. So these are the tools you have in the software. It has some utilities. I will talk about that. It has databases. That's one of the advantages of the software. You can remove any database of anywhere in the world. So huge. So this is the interface of the software, right? And as I said, you can do a grid connected system, you can do a standalone system, you can also do a pumping system. Then the project design and simulation can also be simulated for the three components, for the three areas, either for the grid, the standalone, or for the pumping. Then for the databases, we have the meteorological data, which will give you the geographical site. It will generate the hourly data file for you. It will generate the visualization data for you. You can also import meteorological data from several defined sources. Then the database, we also give you database of the most recent manufacturers and original equipment manufacturers. And I think that's why they keep updating it, because when they get new information, they will update it in their database so that you can pinpointly design a system that will make specification based on the type, the size, and the manufacturer of each of your components. Then it also has tools to help you display a lot of stuff, right? So that is it. Then but the other thing, more other things, these are the things I can really get out of the whole system, but there are many other things it can really do for you. So here we go. So because of time, I won't go through all this, but I think I'll share this slide with us at the end of the day. But this is a typical home standalone system, right? From the PV array, you get to charge controller, the battery, and then the end user. It's typical configuration, right? So as I said, this is the limit of what you can use it for 24-volt system or 12-volt system. Then this is a typical configuration for a medium household, right? Now, the issue of not just the charge controller, which is embedded with inverter anyway, but you also have the issue of maybe gen sets coming in, so such a way that because maybe the PV might not give you the maximum radiation that you need for the day, then the gen can come in and take care of some load, and then as well as have a way of charging the battery in terms of when it's night time. So that is what the system is. The system can range between 200 watt peak. When you see this WP, just make the peak. So when the peak is not there, then it can go below to 2 kilowatts, okay? And so on and so forth. Then finally is you can also have the high power system, which I said is about, can be several of kilovolts, or typically less than 10, okay? So in this case now, the maximum power point tracking comes in together with inverter, and then the generator also is there. Then you have some other kind of additional components that will kind of split the load so that some will go for AC, some will go for DCs, and then different arrangements. We can go through all this at our convenience. So having said that, and having be sure that everyone has put the software, let us now go into the software proper. All right. At this point in the Ashima, I would like you to check our WhatsApp group, and I think one of us is having a challenge logging in.
Yeah, I have shared the link. I have shared the link on the WhatsApp for anyone who couldn't log in to do that.
Yeah. Somebody says he's having difficulty with Zoom. So
okay,
maybe it's to reach. I don't know what the problem is. I can't help.
Don't worry. Let me check it out. Let me check it out.
Okay. Okay. So now, the grid collector system. So if you have opened the software, this is what the software looks like, right? So you first of all, when you open this interface, you choose what do you want to do? Is it a grid collector system? Is it a standalone system with a battery or a pumping system? For me, I would choose standalone. So can you click standalone? When I choose standalone, it's giving me an old system I've designed before. So in that case, I'll go to preliminary design. I'll choose standalone. I'll choose standalone. So when I choose standalone for preliminary design, it will ask me what this system does is this. It's a simulation software. So it's assumed that you have done your system design, but you now want to model it here. It's a modeling software. So you want to model it here. So the first thing to ask you is to define your site and your meteo data. You define your site and your meteo data. Now, any button that is red means it needs input, it needs parameter. So you need to design it. So if I click on meteo data, the system will take me to a meteorologic site and then allow me to impute it. So if I click on the site name, okay. Let me start from the standalone. Let me start from the more technical one. This one is a subset of the one I'm going to teach you now. So if I go to projects, I will say new standalone projects. New standalone project. Good. It will bring me to this bigger interface. New standalone project. That means that I want to go into the project proper. Preliminary design is when you are not sure of yourself. You will use the preliminary design to come up with system recommendation with default values. Then from there, you can now move to the proper project design, which is where we're going to start from. If you can master this, then you can master the other one. Now, this is how the system works. You can all see my interface. There are 3 segments in this place. Number 1 is the project segment. Here, you will put in the value, the name of the project, and all the information that you need here. The second segment is the information. Here, we'll be giving you the information. Like in this place, it says choose the geographical site. So here, we'll be giving you instruction of what you need to do. The second place. Then the last one is the main parameters here. The main parameters will be blunted. But once you have imputed the right parameters, they will turn to green. So there are 3 colors they will be giving you. If they are red in color, it means it is you've not imputed the parameters. If they are orange in color, it means yes, you have imputed the parameters, but they are not optimal. If it now gives you the green color, it is telling you, good job, you have done the good thing, you can now simulate. So if you look at it here, the first main parameter says orientation, user needs, system, and detail losses. The second one gives you the optional things that you can play around with. The last one gives you how you run your simulation, generate reports, maybe do advanced simulation, and then get detailed results. Result overview is just for you to view what you have done. The variant here is just like I said, if you want to run different simulation, you run one based on 4 hours peak sun hour, another one based on 6 hours peak sun hour, another one based on this and based on that, right? You can save different scenarios, or we call them variants. So when you open this interface here, if I click new, it's the same thing. So I'll go to this project overview. Okay, let me click new, for instance, right? It's just the same thing. So I will now come here. I will click, let's say, give it a project name. I'll say design of Abuja phase 1 solar park, for instance, right? When I say that, it will ask me choose the geographic site. I'll go to the database. This is view, this is meteo data, this is help, right? If I have an existing file that I have chosen, I can go here and say new sites. If I click on new sites, the system will take me to a database where I will now choose the sites and the location and other parameters that will come up. So for here, when I say choose new sites, it's updating. After updating, it's giving me somewhere in Spain. So I'll come here, oh, it's giving me somewhere in his home country. I'll come here and I'll type Abuja, right? I'll say search. Or Abuja, Nigeria. So it is giving me Abuja. So this is Abuja for me now. So if you look at the right-hand side, it's giving me Abuja. It's telling me the country is Nigeria. It's giving me the latitude. It's giving me the longitude and what have you. I will now say accept. Gentlemen, that's Abuja for you. There's no doubt about it. So I will say accept selected point. I'll click on it. Okay, now this information pan is now telling me what I should do. This software is very simple and very easy to use. It's telling me, please import the monthly data, meteo data. So all I need to do is to come here and I say import. But let me first of all check whether everything is in place, right? So sometimes what you need to do is just to confirm that everything is in place. So here in this interface, all I need to do is just to click import. I don't have to do anything, but I want to confirm. And for the purpose of teaching, I just want to show you, play around. I'm not going to click anything. I'm not going to add any value because I trust what is giving me is right. If you know the geographical data of Abuja, this thing is top notch. This is perfectly correct. This is Abuja for you, right? But I can decide to check some things, right? For instance, the sum part, if I click on the sum part, it will give me one data that I don't understand. But if you are somebody who wants to probe, you can probe whether it's right or not. In terms of the location of the sun and what have you. Then I can also check the monthly meteo data, right? But I don't need to do that. Is that if I want to adjust some things and I have data from government. So, but now I only want the coordinates and I want to import the coordinates. So I'll come here, I'll click import. At any point, you can pause me anytime you are confused or you don't understand me. Here, I'm playing around with the software. I'll leave some of that for us so that I don't get you confused. So you can as well use NASA data, but this metronome is updated. It's like a third-party company that have used NASA data, PVG's data, and solar TMT data, and what have you, and then put it together and then using it in this software. But if you feel you are savvy, you know more than this, you can now go and import from other software. But for now, we are okay with this. So I will say import. Good. So you can see it has imported those values for me. So this is Abuja data. The temperature, the wind speed, stability, what have you, is there now. So I'll look at it. I'll make sure everything is in order. Then I'll press OK. My job here is to press OK. Because everything is OK. So because everything is OK, I'll press OK. Once it says OK, it's telling me that for Abuja, it will be using the data called this. I will explain this later. And this is the file name it's going to use. I'll say save. I'm okay with it. It has saved it. All these are not too necessary, but let him save it again. Right. So after saying okay, the Abuja has given itself a name and it has come into this place. So at this point, the project is telling me I have given my project a name. I have selected the location, which is the most important thing. It's now asking me to save the project. So I'll come here and I'll click save. So it will save it as a name. So as soon as I click save, which is very important, please don't forget that. After inputting the name and you've imported the meteorological data, and click save, it will give you the next prompt. The next prompt is telling me to choose the plane orientation. And as soon as it's telling me to choose a plane orientation, it's also telling me that the orientation is redded in quotes. The username is also redded, meaning they are not optimal. You can see that the horizon and the near shading have turned green. Why have they turned green? Because I have captured correctly the meteo file. So automatically, it has taken cognizance of the location vis-a-vis the meteo data. So it says, please choose the plane orientation. Choose plane orientation. So I'll come here to orientation, and I'll choose orientation. So here, what is the fuel type? How are we doing it? Are we using tracking? Are we doing what I'll say is a fixed solar panel system, and the azimuth is 30. You can choose 15, can choose 20, but I would like to choose 25. It asks you for the azimuth. You can leave it at 00, right? Or you can choose 5, depending on the location of where you are, this relative to the longitude and the latitude. So as soon as you choose that, it will easily tell you how to reflect here. Okay, I have a hand raised.
Yes, sorry, I didn't get that orientation part.
Or will you chat it on the box while Ninja answers you so that we have like 1 hour to go? Do you mind?
Okay. Okay.
Yes. Thank you. Okay, thank you. So now, what are we doing? The quick optimization for since we are designing for Nigeria, I think we don't have winter, we don't have summer, we don't have those discretization. So just leave it as default, right? Then here, I will explain what all these parameters means. These parameters are like for check. These parameters are for check. It helps you to check that you are not doing badly, right? So they don't have much. So once you notice that these parameters are giving you something very high, which is in the manual, then you adjust your tilt and your azimuth. But like we said last week, for some of these standalone system, your options are limited. The options are limited because you can't start changing the roof. You can't start changing the orientation of the roof. So you just do it minimally. So the next thing, I'll click OK. So if you look at it very well, the orientation have turned green. And the command prompt is telling you that user need is not defined. The user need means the load now. So we're going to go to the load now, which is one of the most important things. We've checked the orientation, we've checked the meteor data, we've checked the sun and what have you. The next thing is what load are we designing for? So I will now go to user needs and click on user needs. It will open a dialog box for me. Later, I will show you how you can also import data using Excel, like we did last week. We have some data in Excel, but if I start doing it now, believe me, it will take our time. But maybe by next week, we'll find, or I'll send the material, how to look at it. You will save it as CSV. Those of you who work with Excel, there's a universal file format or CSV, comma, separated, delimited. So you save it as CSV, and then you save the heading based on a particular template so that the system will understand it. It's like a programming. Systems goes there and it knows the column for emails, it knows the column for load, it goes the column for power, it knows the column for daily usage, and so on and so forth. But for now, let's use the system interface to impute our load. Now, if you remember yesterday, somebody should help me with that load system. I can't remember again. How many lighting do we have? What is their power? I think the power is about it's 15 amp. I think it's 8 number.
It's 15 watts.
It's 15 watts. Thank you, sir. Good. The second one, TV is 1. Wow. And 50. If you want, you can click here and edit the domestic appliance. I don't know which other one is there. Fan, yeah? I don't know. You can name anything, just for you to understand how it is done. What do I name this? Fridge.
Fridge is 150.
Yeah, 150 watts, but that's, you can't put 150 here because it's saying kilowatt hour per day. Normally it's between 1 and 2. I will tell you, if you go to buy fridge in the market, they will tell you about the
That's 0.15.
thank you, 1.15, right? No, or something like that. But it is 2 point anyway. Depends on the kind of fridge anyway, sir. Any kind of size of fridge, but averagely, the average fridge consumes 300 kilowatt hour per year. That's it. Then if you imagine it, that's giving you an average of 1 kilowatt hour per day. So for me, this is a little bit low, but let's just go for the purpose of learning, right? Okay. Do you have a dishwasher? What other appliance do we have there?
Standing fans.
Okay, so this one will be standing fan. Standing fan. And the wattage? 50? Is it 50 or 100?
About 50.
Some are 70, 75.
Whatever, just get the idea. Okay, are we done? Should I put more?
Add more.
Which other one again? And how many number? One is P number. One is
what of AC, air condition?
AC. One AC. We don't have a dishwasher. Let's add dishwasher.
Excuse me.
I'm listening.
The value you use for that fridge is actually low, so maybe we should increase it. The fridge, the deep freezer.
Hello, sorry, you asked the question, sir.
For the fridge,
Yes,
you can use 0.18.
Okay.
It should be higher than 0.15.
It's empty, sir. It's empty, sir. It doesn't 0.18 and 1 is the same. 0.15 is the same. Yeah. What again, sir?
AC.
Okay, AC. What do you put for AC?
1,500 watts.
1.5.
We did not use AC.
Let's not use what we did use. I just want us to do the same thing. What else do we have there? Okay, let's leave for now. Okay. Not that thing, right? Okay. Okay. So the next thing you do
Excuse me, sir. Sorry to.
Okay.
If you want to increase the number of lines, is there any way you can insert a line, a row?
Yeah, yes, there is. I will show you that later. There is. You can increase that. So once again, this is more like what we have, 5.2 kilowatt hour system monthly, but not yet. So here, if you try to exit, the system will remind you that you need to define the hourly distribution. So I'll go to the next tab. There's a tab here called hourly distribution. So on this hourly distribution, you could see that the fridge has only been distributed all day round. The reason being that, if you all agree with me, you use the fridge every day, as in all day, sorry. So, but for the LED lamp, you need to define the hourly usage. So let me teach you this. Here, you right click and left click. If you want to deselect, you right click. If you want to select, you right click. So for the LED, let's say I'll start using it from 6 o'clock. So I'll click on this and be clicking on all the cells and click it for how long that LED will work. Maybe it's 12 hours, I don't know. So let me say 12 hours. I have defined the hourly distribution. For the TV, I'll click on one cell, then be clicking on that's drag across the other cells. Somebody should try this. Someone might have issue doing this, but try it, right? Left click, this is left clicking. If I overshoot, like here, I overshoot, I will now right click. I will deselect it. The standing fan, if it's for all day use, I will put it. But as you know, there's a provision where we made for 8 hours, 6 hours usage, 7 hours usage. So this is where you impute it. And you even specify which period of the day, because this is what will help you to size your system appropriately. So let's say this one, from mid-afternoon, I start using my fan. I click, hold down, and dragging along with my mouse. I'm not using a mouse. So this will be for like 18 hours or whatever number of hours, and so on and so forth. So I can right click now and reduce this one. I can right click and then drag backward, depending on what I want. Can someone try it? When I'm done, I'll click OK. So the system is now giving me about my daily usage and monthly usage, and it's saying that everything is okay. So our usage has been computed. So the system has computed everything for me automatically. Remember this column, it is the hour I use here that the system has been able to compute for me. Remember, I didn't key in anything here, but by specifying it, because it's good you specify it so that it will help determine your peak period, your peak hour, which is very important. So after doing this, I will now say, okay. The user need is now green. Suddenly, the system came up in red and asked me to define it. So I will now click on system design. Any questions so far?
Sorry, just one question. Back to user needs, the interface on user needs.
Okay.
Okay, the place where you have kilowatt day, where wattage average, wattage amp, what are the differences?
No, it's lamp. That one is saying lamp. This one is saying appliance.
Appliance. Okay, then the average, what do we, is because you put AC there, is that why it's saying average? What are the differences?
Yeah. No, that's okay. It. Like your fridge also, your fridge is not like water. You can't say my fridge is so what, no? Is what is the consumption per day.
Okay, all right.
Yeah, because you know how fridge won't function. It's not the same power all through. Okay, Jinaba Midele.
Yeah, sorry for taking you back, please. I missed that part of orientation, so I just wish I can just see the value of the plaintiff and the.
Of course, now it's just to go back and click orientation now.
Yes, like I meet those values. I don't. Okay, 25 and 5. Thank you.
Yeah, here is mostly, you can also use 0 here,
okay.
Most likely.
Okay.
Yeah.
Thank you.
So let me just add, Uche, just please, if you would allow me, just let me add something to the last, because someone asked about the azimuth. So if you have 0 on that azimuth, then then the solar panel is facing south-south. So if you change that azimuth to some certain angle, it's either orientated to the southeast or southwest. That's what the azimuth means. Oh. Then the other one that you have a tilt angle, which is 25. Engineer, which I think 25 will be a bit high for Nigeria.
Yeah. 15.
Yes, thank you.
Okay. In fact, even if you put 5, Nigeria is almost close to the equator. All right. Another question. I think we're making progress. So after I've done the orientation, I've done the user need, the system suddenly remind me that I need to define the system. So I'll click on system. Now the system has three key areas. You can see this area is 1. This area is 1. Let me put my mouse down, my distance out of the way. So then this area is just the procedure. The next area is your battery sets. Then the next area is your battery of temperature. This is very important. this is very important, the temperature of the battery, because that will also affect the lifespan. So here, the system have done the sizing for me based on what I've imputed. But if I don't like the sizing, I'll move on. The only difference I can see here is day of autonomy is 4. It's recommending a 24-volt system for me. In other words, it's telling me 12 volt might not be ideal, right? So here, you can see that when I change this into 3, it gave me the battery, the total amperage battery capacity that I need, and also gave me the suggested power. If you look at it, it's very close to what we have, gentlemen, am I right? Remember that inverter size. What it has done, it has increased my system robustness by 5%. This is called, is it probability of load or something like, something that has to do with assuming things didn't work out. It's more like sensitivity analysis, but you can read that later on. Engineer Richard, your hand is raised. I just guess it's not something you asked on the chat box.
Please, the battery voltage, we are working with a 12-volt battery. Why don't we leave it at 12 volts?
Okay, we'll come to that. This is what the system is recommending to us, right? For me, we are done with 12 volts. Let me just tell you that somehow. We are done because 12 volts is inefficient. Is 12 volts, as we said, is something less than, what do you call it again? 300 watts. I don't think any of us now, if you want to put a solar home system, you'll not be looking at 1 kilowatt or more. So forget 12 volt system. Let's be looking at 24 volt system, but that's by the way. We'll still come to that, sir. Okay, and besides, it's not me that came up with this, sir. It's the system. It just gave me what is feasible. So now, it's telling me to choose the model to finish up this design. It says please choose battery model. So here is battery models. If you click here, you see all the models in the market. There is Tesla, there is Voltron Energy. Some you know, some I don't know. There's LG. So I don't know which one you want us to use. Or you can say all manufacturer. Then it will ask you for what technology. Is it lead acid? Is it lithium ion? So let us choose lead acid. So we are saying, I'm not interested in the manufacturer, but I just want to, I'm interested in the technology. What technology am I using for the battery? Then later on, I can go to the market and buy any hell of a manufacturer. So I'll choose lead acid. So with lead acid, I'll open this flyout. It will give me all the lead acids in the market. So I'll scroll down. These are small batteries. Then here, the big one comes. So that has killed off everything. Lead acid is 12 volts. So you can see the result already. So I'll choose, is it 200 or 100 amp hour we have there? I think it's 100, 12 volts, 100 amp.
200.
100?
200.
Whichever. My own is just learn the process, just learn the protocol. So it has given me what we have. What did it say? He said we need, just like what the argument we had last time. He said we need 5 batteries in parallel and 2 in series, right? Okay. So number of batteries is 10. Then the system also said the next prompt I have here says I should choose a PV module. So here it has given me all the parameters of what I have designed. Later it will give me a good report. So don't worry about this. Okay, so the next thing says choose your PV module. So it means I'm done with the battery. So I'll go to, there is a tab here. There's a second tab here with PV arrays. So I'll choose it. Are you seeing it?
Yes.
Good. So I'll choose it. It will open another interface for me. It will open another interface for me now. For me to choose the PV array, you see how to choose a PV module. So here's a bit tricky. Here's a bit tricky. Here is one good thing. If I feel I don't know what I'm doing, I'll simply leave this no sizing. So it has sized the system for me. But if I say no sizing, then I'll resize myself. Take note of that. So for the PV module now, let's go. Select PV module. So all modules, so you say all module. Which year? There are so many of them from 2011 up to 2018. Right? Is it generic? I will choose what type of module do I want. If I say all manufacturers, if I want to take in terms of manufacturer or generic, it all depends on what you want. Let me say if there's Jinko Solar. Jinko. I mean, there are many of them. There's so many of them, but let me just see if there's anyone. So there are many of them. Of course, I suppose that these are big industrial players, right? So let me leave generic and go to, what was it that I used last time? If I say favorite. Available now. Well, it just depends. Sorry, I'm just taking your time like this. Okay, let's say from 2018. It will go into the database and probe the database, and then come up with let's just take any name we can see there. Yeah, I've seen Jinko Solar. Never. Okay, now what module do we want? I'll open the flyer for the modules, right? Poly, mono, 200 watts. Jinko has up to 610 watt module. Manufactured in 2022. So you can see how current this software is. It's even giving you the brand of PV module that have been manufactured in 2022. Right? I just put Jinko Solar there because I watched one of their videos recently. Okay, but you can choose whichever one you want. And also choose, is it a bifacial? Is it a mono? Is it a poly? And so on and so forth. So I just don't know which one to choose, but let me choose whatever, 60 cell. This number here, I think it represents cells. So this is the module name. So 60 cells, 72 cells, and what have you. So let me just choose anyone. Doesn't matter. It will give me the voltage, the other parameters, and the MPPT voltage too. So you could see that the system is also giving you some other idea. Then the next thing, I will choose what type of charge controller I want. So I think we've explained all this. So let me just choose this one, the MPPT. I think that one is automatic. Once you choose it, it will automatically choose the appropriate one for you. So that's choosing the one appropriate for me. I can also go here, and if I want to have a favorite, if I know anyone, all manufacturers. Okay, if I want to go in terms of manufacturers, then I can choose whichever one. But for me, I don't want all this trouble. I'll just go to generic, and I'll choose this to make life easy for me. So you can see there's no message here. And because there's no message, I'm confident I've done the right thing. Later on, I'll show us how to play around with the academic side of it. Okay. So now, look at the message I got here now. It says, ready for simulation. means I have been able to impute all the necessary things that ought to be imputed. I've done I started by giving the name. I saved it. I went here and I chose a site and
let's go back to the system and look at the backup.
No, I won't do backup. Backup is generator. I won't do backup now. Here. It's a standalone system. If you want to do backup, you can now click this and then you impute the value for the generator backup. Okay. I might choose to leave that to you to play around with that. Okay. So I started by giving it the name, choosing a site where the solar panel is going to be installed. I imported it. That's the reason I did. I just confirmed that it's okay. I click import twice. And then it came here automatically. When it came here automatically, it reminded me to save so that I can save both the PV site location and the name of the project. That was stage 1. And that is this. Okay, 2 hands are raised. 2 hands are raised.
Yes, can I speak?
Yes.
Go ahead, sir.
Thank you. Well, the other one of our colleagues said something about the tab, the backup tab. Why are we not going forward to that?
Okay, because we are designing a standalone system without a backup generator. The backup is when you are doing a hybrid system. I want to involve generator.
Okay.
Yes, sir.
Thank you. Can I speak now?
Go ahead, sir.
I noticed that you didn't mention the total number of PV, solar PV that the software bring up. Is it deliberate?
No, sir. It's an omission.
Okay. Thank you.
It's an omission, but I'm waiting for my final results. So can I go back there now?
All right, sir. Thank you.
I can't even see it here. Is it there? I'm waiting for my final report.
Okay.
Yeah, it's good you draw my attention to it. I'm not even seeing it. Is it there?
I can see number of modules and string. I don't know. Look closely. You have modules in series. You have 1, and the number of strings. I think you have 2. I'm trying to see if it has anywhere where it states the total number of PV modules.
Okay, I think in the final report, we'll look at that.
Yeah, but it will present all of this in the final report.
Okay, then if I also want to emphasize is that if I'm not comfortable with this now, I can also come here and say no sizing. I will come here and impute my total plant power. My total plant hour, once I impute it here, the system will come up with a report for me. Okay, let's continue until we get to the end.
But please, you have clicked on no sizing. I think you should remove it.
It's removed.
Can't we try to run the simulation and then we can come and do for no sizing?
That's exactly what we're calling now.
Let's run the simulation.
Okay, so as a reminder, what we've done so far, I have done this. Then the next thing I did was I'm running on 1 variant. Okay, I can save this variant. I can call it variation 1, right? I can call it B1 or South, whatever name, you know what I mean. So I've saved it so that if I come tomorrow, I can do another simulation, maybe kernel or change some parameters, I will save taken as variation 2. So after doing that, I imputed the orientation, I did the user need, I did the system, and then finally I'll run the simulation. So this is the result of the simulation. This is the interface of the simulation. Here you see all the parameters. Then on this right-hand side, you see the different reports that you can run from this software. So the first of them will be the system reports, which is the first icon here. So that's the first icon I'll click. So it will generate a report for me. Yeah, because I'm using a trial version, it will like to put it up there. So the first one page, I'm just clicking enter. It will give me the whole project summary. Then the system summary, it will give me whatever I need. The thing is giving me the number of PV modules is there. It says 2 units. Based on the few things we imputed there, we didn't impute much. We didn't impute AC. It was AC that jacks up things. It says 2 units. The technology of the battery is lead acid battery. Number of units 10. Voltage 24. Capacity of the battery 500 amp hour. Number of modules 2. The total is 50 watts peak, and so on and so forth. So this is, they'll give you the project summary of the whole thing, of the whole system. That is, so the first page gives you the cover page, which I know you can save and convert and customize. The second one will give you the project summary and the system summary, so as the results. The third one will now give you the general requirements, the type of module. Can we all see my screen? I think it's a little bit small. Yeah. Oh, sorry. So the second page will give you the PV characteristics, who is the manufacturer, what is the model size, the battery parameters this way, the module parameter this way, right? It also gives you things about the battery management, the controller size, and the make, and so on and so forth, and even the area that the PV module will contain. Sometimes you can also do the design using the area that you want the PV module. By using the area, the limited area you have, like your rooftop, you are constraining the system to come up with the best configuration vis-a-vis the size of the module you're using. So it's like more work for the system. The system will now size, instead of giving you 200 watt module, it can start giving you like 450, 400, 425 watts. And they make so as to utilize that limitation of area. So depending on other things that I've done, this is not just all that the report can give. If I design other parameters, it will give me those further reports. Okay, so I can close this here. Okay, it's still going on, sir. So page 4, 2 hands are raised, and wait, I'll surely come for you. This is what our energy load, what we imputed ab initio, that just brought it out for us here. Again, this is the average need. Then number 5, it will now give you some of these charts showing you the load distribution and the load balancing and or some other informations that will help you to make a case. Then number 6, it will give you the Sankey diagram to tell you about the losses. This is more like academics, I would say, but this is where you begin to look at the system, you begin to critique the component you are using, and then look for ways to optimize the system. And number 7, it will give you this special graph showing you the irradiation amount and some other information that has to do with the meteorological data. Okay, at the end of the day, I can simply save it as PDF. I can print it. I can copy it. I can export it and use it to do other simulation. I can also edit the cover page and I can close it. Question. All right, where do I start?
Can I go ahead?
Yeah, go on.
If you go to page 3 of the simulation report, please.
Okay. It's opening.
After the cover page, the second page, and then the third page.
Hold on. Here.
Can you please enlarge it a bit? Yes, my question is on the battery. If you can please scroll down. Battery. No. Battery. The battery here, by your choice, the choice we made together is 12 volts, 100 amps. Then battery pack characteristics. It said voltage 24 volts. So why is there difference between this and this? That's the 12 volts and the 24 volts.
Okay, the 12 volts, if you look at where it said 12 volts, he said we should do 10 batteries and we'll string it into 2 to get, yes. So he's assuming, he's looking at the battery, let me say this, most modern batteries comes in battery pack, like a rack.
Okay, I've understood now. Our operating voltage is 12 volts. So he has arranged the 12 volts 100 amp hour in a set of 5 in parallel.
Yeah.
In 2 sets of 5 in parallel.
Thank you. And those 2 sets, some battery manufacturer will make those 2 strings, will put them in 1. That's how they do it. I mean, they can be like 1 battery. It will form like a unit. But that's usually, some lithium, some of these new batteries, some of these Tesla batteries, they come into 2 volts. So they arrange it in packs. Some of us have seen it. Those old phones that we used to use those days. Let's not go there. Okay, the next question.
Oh, okay, all right. Sorry, my own question is back to the PVC, the system tab. I think there's a.
So now that we've finished our design, we'll go back to the original interface. Let me just show you some of the things that one can also do with this software. There's an open PV self-help. There are video tutorials to help you understand more. And there are preliminary design you can also do by clicking on preliminary design. I say standalone. I will choose a site data. I'll call it prelim, right? The country is chosen. I can open the sites. Yeah, I can open the site, and the site is chosen for me automatically. I can check the sun hour, everything is okay. I can click on save or close. I can, if I don't like Nigeria, I can choose any country of my choice. This is just if you want to do a quick one. Of course, if you say all countries, it will give you Nigeria. Then Nigeria, I can collect data for Port Harcourt, I can collect for Benin, I can collect for Abuja. So let me say I want to use the one for Benin. So these are the sites in Nigeria they've been able to capture. So for Abuja, you can use Abuja for anything in the north, and Port Harcourt for everything in the south, and Benin for anything in between. So the material data has turned green. It means I'm done. Next, I'll go to user need. Under user needs, I will impute what we just imputed. Number of panels. Light is what? 8. And each one is what? 15 watts per day. TV is 1. and the watt per day is 75 or thereabout. Other domestic appliance, I don't know what wattage I'll give them, but let me say they have 100 watts. Then my fridge, I have one fridge, and it consumes, what does it consume? 0.5, 0.3, yeah, whatever. Then I have, okay, I can stop here, or I can go further and further and further. I'll specify the hour for the lamp. So I'm just doing it randomly. Have somebody tried doing this and having difficulty? The TV start every evening, or depends on what I think is right. Domestic appliance, I don't know what kind of appliance is it, but I just want to specify this thing could just be 2 hours usage, right? It could be a different, it could be something like you just use 2 hours a day or so. Okay, 2 hands are raised. Can I still ask your question while I teach on the fly?
Okay,
How
sorry.
do you
I think someone
insert
asked the other
additional
time.
rules on the load calculation?
That's what I want to ask you. Additional rules for the user needs.
Okay, okay.
Can I ask my question too?
Okay.
Yes, mine is different from what is being said now. I'm looking at a situation whereby you are using thin film as your PV mode.
Mm-hmm.
And in this case, instead of putting it on your roof or on your car park, you decided to put it on your facade. That is by the side on your building. Let's assume you have a circular building.
Facing
large area, facing facing the east.
Yeah, yeah.
How effective would that be?
Yeah, it will be effective, but you will not maximize. It will give you optimal output. I think that's just implication. Yeah. So it will be more of incident lights, incident radiation.
Can the large area compensate for the for the effectiveness?
Yes, yes. But then you now have to evaluate it in terms of the costs now.
That's right.
It will, okay. Yes.
Thank you.
It will. Maybe it will be giving you 30% output or 25% output as against 100%.
Okay.
Yeah, I think that's the next thing that's going to happen in a lot of places in Europe. This issue of shading and glazing is becoming something that is upcoming.
Thank you.
Okay, somebody was asking about adding more cells. Any other question? What I'll suggest, I will explore it. I will explore that, but I might not give you the answer. But I know there's a place to do it. Is there are 1 or 2 columns remaining? What you do is those other power outage, you can aggregate them. I can say other appliance, right? I will calculate the total power and give them 200, for instance. How about that? I specify the hour, depending on how they fall in. Go on, sir.
Please, in a situation whereby we have our total load already, and they want to use the software, just put it in one of the cells, right?
But it will help you in system optimization. That's just the point, sir. The whole loads don't come in at once. So what this thing is trying to help you do is to help you get those small details right.
Okay.
You know, if one optimizes the system, and that's what we should, and that's why this training and all this knowledge sharing is going on. There's a way you optimize your system, and you begin to know